Hey everybody, welcome back to Lean on Success, where process improvement is self-improvement. My name is Ben, I'm a Lean Six Sigma Master Black Belt, and on this episode, we are continuing our saga of White Belt Part 2. All right, I'm trying to do some Duolingo with y'all, give y'all some different languages to think about. Okay, so this is part 2 in our white belt series. This is an introduction to Lean Six Sigma. I'm going to break apart and demystify a lot of the definitions and the history behind Lean Six Sigma for you. And this particular episode is going to be dedicated to Lean. So we're going to talk about the history of Lean and some of its fundamental concepts. So without further ado, let's jump right in. So to understand the history of Lean, we have to look at the automotive industry. And the automotive industry, as you know it today, pretty much starts with a guy named Carl Benz. All right. Now, he was from Germany, obviously. He is the Benz and Mercedes-Benz. And he is credited with creating the first production automobile that happened in 1885. Now, this car obviously was a successor to your horse and buggy that was very popular in those days. And these cars were custom builds by master craftsmen. So think about blacksmiths and carpenters and people that have been working in these industries for decades, right? These were very skilled tradesmen that were assembling these vehicles. So you can imagine that while there was a very high quality product that came out of that, and they could customize these automobiles to your particular dimensions and your style, that takes a long time to create custom vehicles, right? And also, money, 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 money. You're going to pay a lot of money for that. So although this was an innovation in many ways, one of the barriers is that the average person at that time couldn't really afford an automobile because of how long the lead times were and how expensive they were. Now, all of a sudden, a young American from Detroit bursts onto the scene, Mr. Henry Ford, right? None of you may have heard of Carl Benz, but everybody knows who Henry Ford is, right? He has a lot of things credited to him that he actually wasn't responsible for. He did not create or invent the assembly line that existed well before he came along. And he didn't create the concept of interchangeable parts because that had been around for hundreds of years. However, he did manage to perfect both of these processes. He revolutionized the way that the assembly line could be used to create automobiles, and also had interchangeable parts as part of that, along with many other innovations that he revolutionized and perfected. He came up with a very efficient production process. That means that you could make inexpensive cars fairly quickly. And for the first time in the history of the world, the average working family could afford a vehicle because of how cheaply these cars were made. Now, with anything that's made cheap, one of the big problems that you're going to face is persistent quality issues. They were constantly breaking down. There were a lot of problems with the parts and the way they were put together. And this created kind of a black eye on the reputation of Ford. So that was one of the big problems that they faced early on. One of the other big problems they faced was that Henry Ford himself was a bit of a cult of personality. Look in my eyes, what do you see? Oh, I'm a cult of personality. Oh, sorry. Sorry. Got a little bit carried away there. So what do I mean by cult of personality? Well, cult of personality is an individual that basically dominates a particular culture or group of people with just their personality and their presence and their character. And Henry Ford was absolutely one of those people. He had a lot of mantras, and he's known for his charitableness. He's known for a lot of positive things like increasing wages and paying a fair wage to workers, inventing the 40-hour work week so that the workers would have more time to spend with their families. He came up with a lot of good things. He also came up with simplified manufacturing. Now, this meant that he could take unskilled workers off the street and train them very easily into his process. He's also credited with saying that customers who bought his Model T Fords could have them in any color they wanted so long as it's black, because black paint was cheapest and it's difficult to run a process where you got multiple colors. So Ford wasn't so much interested in trying to conform to what the customers wanted. He was really more interested in revolutionizing the industry and creating a better mousetrap so that his customers would want what he was giving them. He very much had that mentality that's very backwards from how we think of things today, and really sets the scene for lean manufacturing to become popular. He was very much a proponent of self-reliance and the right to repair. So basically, Even though your Ford's got a lot of quality problems, hey, we'll give you the tools to fix it yourself. It's very easy to fix. All you got to do is get in there and fix it. You'll never need to buy another car ever again. And so you can kind of see how these mantras kind of set the stage for overall customer dissatisfaction within the automobile industry. So now we need to shift forward a few decades and talk about a guy you may have never heard of. His name is Taiichi Ono, and he was an industrial engineer from Japan, and he's known as the father of the Toyota production system. Now, Mr. Ono studied a lot of efficiencies and inventions that became popular in the United States. He absolutely studied Ford's assembly line. He also studied things like NASCAR because he was interested in the pit stops and how quickly they were able to get the cars back on the road. He even studied things like supermarkets and how our supply chain was able to replenish goods. And so he took a lot of these concepts and he started to observe and watch his manufacturing process in his plants. And one of the things that he came up with as he started to watch and observe his own manufacturing process at Toyota is that there were a bunch of what we call wastes that I talked about in part one. There were a lot of inefficiencies and barriers that were standing in the way of delivering the customers what they wanted. Also, one of the key differences between Mr. Ono and Mr. Ford is that he perceived the frontline worker as the primary problem solver. He perceived that the frontline worker is an expert on that vehicle, on that car. They're building the car. They understand that vehicle more than anyone else, and they hear the customer's voice the loudest because they're right on the front line delivering that car to the customers. So he figured out that we need to be able to employ workers to become part of the solutioning process. They're not just people who put cars together. We also need to depend on their expertise and their thought process to help us solve quality problems. And as a result, to this day, Toyotas are known to be among the most reliable cars in the world. Now we need to talk about another revolutionary in lean production. His name is Jim Womack. And I've actually had the pleasure of meeting Mr. Womack, and he would probably be very upset that I am even showing his picture right now because he is among the most humble people you've ever met, and he never likes to take credit for how important he's been in how we apply lean manufacturing today. Mr. Womack is a former research director at MIT. I actually should be referring to him as Dr. Womack because he earned his PhD from MIT. He began studying automobile manufacturing as part of different research grants and studies that he conducted over about a 15 to 20 year period. He actually was the person that coined the term lean production. So in the early days, you would never hear Toyota engineers call it lean. They call it the Toyota production system. Now, Mr. Womack popularized applications of lean outside of the auto manufacturing industry, and he is a big reason why this channel exists today. So now let's pivot and talk about the 7 wastes. This is the heartbeat of lean manufacturing. And before we get into them, it's important that we tell you the Japanese word for waste, which is muda. Okay, muda actually translates to a word far harsher than waste. This is a family show, so we're just going to refer to it as manure. Okay, so when the Japanese are talking about waste, they're talking about something that is repulsive, that is disgusting, that has no further use in the process. So there is a very emotional reaction when you're talking about waste in terms of lean. So it's important for us to attach the emotion to it. Here are the 7 types of muda that Mr. Ono identified in his process. You have overproduction. You have correction, what we would call defects. You have inventory, which can have positive connotations depending upon what industry you're in, but it's definitely a waste from a production standpoint. You have motion, overprocessing, conveyance, and waiting. So let's break down each of these. Let's talk about motion first, okay? So motion, the waste of motion, is any unnecessary movement of people or of raw materials, all right? Now, actually, a best practice in terms of eliminating this waste is Starbucks. The next time you walk into Starbucks, I want you to pay close attention to the person taking your order. You'll see that they'll punch your order into their system. They'll write your name on a cup. I want you to notice how many steps that person takes to deliver your cup to the barista that is placing your order. And what you're going to find is that they take 0 steps, right? They have eliminated motion. They put the cup right down beside them. The espresso machine is directly next to where the cash register is so that the person taking your order has to take very few steps. And I've been in a lot of Starbucks all over the country. And one thing that I noticed is that the footprint of the actual workspace within a Starbucks is pretty much the same in every one that I've seen, and is pretty small when you look at the actual workspace. And that's because Starbucks has designed their workspaces to eliminate the amount of motion so that they can take more orders and improve their production levels. Let's talk about overproduction. Okay. Overproduction is any time that you produce more than what's needed. Right. So one of the biggest examples of this, and one I'm sure you'll relate to, is Thanksgiving. Right. You know, you've got the big turkey or whatever your particular tradition is, and the food is overwhelming. Right. We're marketed by grocery stores and by different companies on television that you just get absolutely stuffed during Thanksgiving. Right. You got your turkey during the dinner, then you got your turkey sandwiches, and you got your turkey hash, and your turkey jerky, and you're trying to come up with all these 50 million ways to use as leftover turkey parts that you have. And now in reality, not just during the holidays, but about 30% of the United States food supply is actually lost due to waste because we're producing more food than what we can actually consume. So when you talk about or think about overproduction, a good example is to think about all the food that gets thrown away, not just during the holiday season, but on a daily basis. Okay, so next let's talk about inventory, right? So what happens with overproduction is that when you have more than what you need, what often happens is that anything that's left over goes into inventory. So inventory, it's important to note, is not just the actual materials that are produced but not used. It's the liability that those particular materials create. When you think about warehouses, for example, warehouses cost a lot of money to maintain. There's a lot of hazards, physical hazards that come with things being stacked, heavy things being stacked around in warehouses, right? Or if you have something like food products that have to be climate controlled, imagine the costs associated with climate controlling large areas. So there's a huge liability that's associated with storing things that you're not going to be able to immediately use. And companies are trying every day to improve their supply chains and minimize the amount of inventory that they have left because of all of these liabilities that they face. Let's talk about conveyance, transportation. Now, this differs from motion. If you remember, motion was the unnecessary movement of people or raw materials. Conveyance or transportation refers to the unnecessary movement of finished goods, right? So you may have a manufacturing plant in China, but the manufacturing plant in China has to drive those goods to the dock in China, and they have to then either fly or ship those goods over to a dock or an airport to the United States. From there, it gets flown or driven to a distribution center regionally in your area. And then from that regional distribution center is then driven using last mile services to your home or to grocery stores where you go. So all of the costs associated with that is referring to transportation. In fact, it's estimated that roughly 70 to 80% of unit cost is attributed to transportation and storage costs. So transportation and inventory are major problems from a supply chain standpoint. They are a driving factor as to what set the costs and what sets the prices for many of the goods that we buy. Let's talk about correction or defects. This is pretty self-explanatory. This refers to the time and the resources spent fixing problems, fixing defects. I'm sure at some point most of you have worked in a position where you had to spend a significant amount of your time fixing issues that either you caused or really more commonly was somebody else caused, right? There are entire departments in most industries associated with fixing problems or fixing errors that other people made. And when I think about a best practice, I think about a quote from the great John Wooden, a legendary college basketball coach. And his quote is, "If you don't have time to do it right the first time, when are you going to have time to do it over again?" Now let's talk about over-processing, okay? So over-processing is any extra steps in your process that don't really add value to the customer. Any extra steps that don't really transform the input into valuable output, right? One of the most common examples of this are any type of audit, right? Now, some audits are necessary because they're required by certain government agencies or certain rules and regulations. But it's important to remember that you cannot audit quality into a process. The best case scenario for any audit is you're able to identify whether defects exist or not. They don't actually fix anything. So while we see audits as absolutely necessary in certain instances because the government requires us to, or the customer requires us to, they don't actually add any value to the customer. The last waste we're going to cover here is waiting. And this is non-productive time. Any time that you're sitting idle, not allowing the output to move forward. And here's the example we all can relate to, the good old DMV, right? You just dread doing this. Some of your DMVs, I know the one in my location where I live, they've become a lot better with setting appointments and allowing you to do more transactions online so that you don't have to go through this. But, you know, if you've got a serious, unusual transaction, you know that that line is waiting for you at the DMV. So that's it for this video. We're going to go into part 3 next time, and we're going to talk about Six Sigma. We're going to go over the overview and history of Six Sigma. If you enjoyed this video, please like and subscribe. If you didn't enjoy this video, please like and subscribe. If you really didn't care less about this video, please like and subscribe. Help me out in the algorithm, and I'll see you next time.